Let's have a look at more advanced trinomials now in the second part on factorizing trinomials. And the reason I say they're more advanced is because this time we have a coefficient in front of the first term, in front of the y squared term in this case. So we're not only looking for factors of 28, which is the constant number, we're also looking for factors of 5. So the best way to do this is with what I call the cross method. We draw a cross on which to find out the factors. Now, a lot of people start to get very confused about where things go on the cross. So the best way I can explain it is 5, being that coefficient there, is on the left-hand side of the trinomial. So we're going to write its factors down the left-hand side of the cross. And again, because it's a prime number, we know that we only have the option of 5 times 1 or 1 times 5 as a factor pair. And then, because 28 is on the right-hand side of the trinomial, we're going to write its factors down the right-hand side of the cross. And here we have a number of different options. So what the best thing is to do is just to start off with any of the options and see how that works out. So I'm going to choose 4 times 7. And then what you need to do is multiply down the arms of the cross. So you're going to be multiplying down like that, and 5 times 7 would give you 35. This is your check of whether it's going to work for this particular trinomial. And 4 times 1 is 4. Then you need to see, can 35 and 4 give you the middle number either through addition or subtraction? And if you've watched part 1 and taken in all the rules, you'll realize that because that sign is a negative, we're going to be looking at a subtraction situation over here. Well, 4 and 35 through subtraction cannot give us 13, so that's incorrect. So the first thing you do then is you just swap those two factors around before you start looking for other factors. So instead of saying 4 times 7, you say 7 times 4. And then again, you multiply down the arms, get rid of those because you know that they didn't work. I don't do this in pencil and erase things because I want to see what worked and what didn't work so that I don't go and keep double checking the same thing over and over. So multiplying down the arms now, I've got 7 times 1 is 7 and 5 times 4 is 20. And we can see that 20 and 7 through subtraction can definitely give us 13. So when we found the correct combination, then we're going to read what our two brackets are being by reading a cross like that. So setting up my two brackets now. In my first bracket, that's telling me my coefficient and my constant, but I mustn't forget that I've got a y squared involved as well, which is going to break up into the two brackets as y times y. So this is actually, and if you want to, you can put it in there to remind yourself, that's going to become 5y and 7. And the other bracket, I'm going to read off the bottom, horizontally off the bottom. So that's going to become 1y and 4. And then if we go through the rules that we learnt in part 1, if the second sign is negative, it means that the signs in the two brackets are going to be different. And what is the biggest one going to be? It's going to be negative. That's what we learnt in part 1. But now it's not quite that simple. The larger combination of whatever the inner two give me or the outer two give me, that's the one that's going to get the negative. So I don't have to worry about the variables, just the numbers. 5 times 4 is 20 and 7 times 1 is 7. So the larger combination is 5 times 4, which is 20. So that one's going to get the negative and the other one will get the positive because the signs in the brackets are different and the larger one is negative. Let's have a look at this example over here where we've got two variables. So when this happens, your a variable is going in descending powers of a squared, a to the power of 1, and this actually means a to the power of 0 because it's absent. And then your other variable is going in ascending powers of the variable. So there's no b here, then there's b squared. So we have to accommodate both those variables, but they're only going to come in right at the end. First, we're going to worry about the numbers. So once again, 5 is prime, so we've only got 5 times 1. 36, we've got a lot of combinations. So let's think of what we could do for 36. Let's say, for argument's sake, we came up with 9 times 4. Then multiplying down the arms again, down the arms of the cross diagonally. 1 times 9 is 9, and 5 times 4 is 20. Right, so let's look at our signs here. This sign is telling me that the signs in the brackets are the same, and they're both negative. In other words, we're going to have an addition situation over here. Well, 20 plus 9 doesn't give me 27. So let's try, first of all, just by flipping those two around. 4 times 9. So multiplying down the arms now. 5 times 9 is 45. And 4 times 1 is 4. We're even further away from the answer. So what we need to do now is try and find another combination that can give us 36. So let's try 12 times 3. Again, multiplying down, 12 times 1 would give me 12. And 5 times 3 is 15. I'm in an addition situation. Can 12 and 15 give me 27? Yes, they can. So now I just need to remember that because I'm reading across now for my brackets, I need to just remember that this first one is going to have an A attached to it, and the second one on the other side is going to have a B attached to it. And then I can read off my two brackets exactly as they are. So I'm going to have 5A and 12B. The other bracket's going to be 1A and 3B. I always put the signs in last just to double check. The signs in the brackets are the same, and they're both negative. So once you start to get familiar with how this cross works, it actually becomes quite easy, and just realize you might have to try quite a few combinations before you find the right one. But let's do another example, because practice definitely makes things improve. So we're going to do 13x squared plus 21xy minus 10y squared. So again, we've got two variables, but it doesn't matter. We know now what to do with them. And let's start by finding factors of 13 on the left-hand side of the cross. And again, it's a prime number, so 13 times 1 is our only option. 10 is not prime, so we have a few different options we can try. Let's try 5 times 2. Right, multiplying down the arms again. 13 times 2 is 26. 5 times 1 is 5. Right, looking at this, the signs in the brackets are different, and the biggest combination is positive. As soon as they're different, it means that this is going to be a subtraction situation, and 26 minus 5 can give me 21. So this time I found my correct combos straight away, and reading across, I'm going to have 13x and 5y. And reading across at the bottom, I'm going to have 1x and 2y. The signs in the brackets are different, and the biggest combination is positive. So I'm looking at the combinations of the inners. When we do FOIL, multiplying out the brackets, those are called the inners. And looking at the outers. So the inners are giving me, I'm only worried about the numbers. The inners are giving me 5. The outers are giving me 26. So the biggest combination has to get positive. So the 26 is getting positive, and the other one is getting negative. One last example, and then you should be champions at this. 15a squared minus 29ab minus 14b squared. Okay, so this is the first time we've come across a coefficient of the first term that is not a prime number. So we've got options here and we've got options there. So in this case, you might hit it lucky, or you might start to realize what to look for, because as you do more and more of these, you'll start to see, oh, that combination is going to work, that combination isn't going to work. But for now, let's just try 5 times 3 for the 15. And then let's try 7 times 2 for the 14. So multiplying down, 5 times 2 is 10, 7 times 3 is 21, 21 and 10 can't give me 29, and secondly, I need to be subtracting here to get the right answer. So the first thing I do is I swap one of the combos around. So now I'm looking, sorry about that, now I'm looking at 5 times 7 is 35, and 2 times 3 is 6. Can 35 minus 6 give me 29? Yes, it can. Once you've found that, you know that you're pretty much home and dry. So we're going to read across for there. So because we have an A variable and a B variable, it's going to be 5A and 2B. And here, reading across, we're going to have 3A and 7B. The signs in the brackets are different, and the bigger combination is negative. So my inners are giving me 6 when I multiply them together, and my outers are giving me 35 when I multiply them together. So the outers are definitely the larger. Signs are different. The larger one is negative. Give the other one positive.